Alright, so it's 6:30 in the evening here in Sweden. I'm sure it is some other time where you are at. Hello, today I want to try, so the hypothesis is that it should be fairly simple to make a clock divider for the Sync24 that you get out of 606 or into the 303. Loads of Roland stuff, loads of other stuff. DinSync or Sync24 is what it's called. So it's one of those DIN jacks that this information comes out of, and which is not MIDI. It looks like MIDI, but it is not MIDI. And so what you have in this jack, let me find a good pen. So in this jack there are 5 pins, just like the MIDI jack, and this should be start, stop. This should be reset. Here's the clock, so that's the really important one in this case. And this is the fill in, which we had on all the old drum machines from the 80s. So I'm gonna solder up, and then the sleeve is of course ground. I don't know if this pin is also ground, but the sleeve is, so it doesn't matter. So what we're gonna do, I'm gonna solder this, and then, so I have here, I have a, just a moment. So out of this, the clock here is Sync24, so there's 24 pulses per quarter note, PPQ I think it's called. So 24 pulses per quarter note. So to get a quarter note, we need to divide it by 24. And we could do that. So what I have is one 4017, and the 4017 is just a decade counter, counting from 0 to 9. So we let that count 0, 1, let's see, 2, 3, 4, 5. So 6 digits. So on number 5, we will take that output and into a 4520 in this case, which is a dual synchronous binary counter. So we're back in binary counter thingy, and this is basically a clock divider. So when this one, when output 5 goes to the clock input of this one will start counting binary, which means that we can divide this. So we have 6, and then we can not divide, we times that by 2 on the first one, and then for each bit we multiply by 2. So here we see that on the second bit already we are up in 24. So I think this will work, but I have no idea actually. So that's why I thought this was a interesting thing to do. And now I'm in one of these things. I hope you can hear me. Let's see, and we're gonna get interesting thing. Yes, you can hear me. Good. That's always good. I've been rambling for 5 minutes, and then I start thinking if you hear me or not. The reason I take the 4520 is because it is 2 4-bit counters, and that means that I can use one side for the gate signal and one side for LEDs. So we see that something is happening. Let me just put some cables on here. So always a good question if this is the jack or the plug. On the back side, let's put red here, and let's take a white one as well on the other side. Right. Ja. Don't pop. Traffic going through the room. Metal there needed to be heated up. So I want to start by just measuring the output here, just to make sure that we actually get the clock. I'm guessing that is the clock. And then we need, so DinSync uses just normal MIDI cables, so you can use MIDI cables for this. Or DinSync cables for MIDI actually, because DinSync came before MIDI, so right should be right, I guess. Very jittery here. Okay, let's see. Alright. It's in this pin. I don't know, I don't get any reading on this at all. This is not good entertainment. Turn it off and let me get another drum machine. So here's the Roland TR707. It's a much newer, well, not much, but it's a newer machine than the TR606. I don't know, there's something wrong with this. There is some kind of, I think there's a cap or something that needs to be changed there. Anyway, so this one is a bit newer, so this one actually has MIDI in and out, but also sync. So this was in the transition between the two techniques, I guess. Now I just need to make sure I can get this one started. I could. Let's see if we get anything now. Starts jumbling here as well. Again, nothing. This makes me wonder. So the thing is, I didn't really check signals and stuff like that beforehand, so you have to excuse. This is how I work sometimes. I just get an idea and just want to try it. You're just here for the ride, I guess, right now. Let's what can we do? Let's do, I had some LEDs just before. If we take an LED, that one, and replay. this might be ground. Let's see. So we start, we go in here. So okay, I read that wrong. So probably that middle pin is the ground pin, because if I press play, this one goes high. So red one is probably start stop. So if we take this one instead, come on. Yeah, now we have a nice little square wave here, which is the clock. Right, and this should probably, if we turn this up, it should go faster, which it does, and slower. All right. This would have been a short video otherwise. Okay, so I need to fix this then. Let's see, I'm checking the I'm not good at checking the chat while I'm also doing this, but I'll try to check it a bit from time to time, which I'm doing now. So hello everyone, and how much is the oscilloscope? Not that much. I don't remember how much. I know there's a link in one of my videos where you can buy it pre-assembled, because you can buy it as a kit when it's even less money, and then you can buy it pre-assembled. I think it's below $20. So for an oscilloscope that works with audio, it's fine. There's actually, just today I was let's see, I'll reset this and you can see what the name of the company is, because I was in at their webpage today. JYEtech.com is the company that makes this. So they've actually made the DS0138 Mini, which is a bit smaller, but you can connect it via USB to the computer and record your waveforms. And I would have loved to have that in this one as well, because some things I'm going to do in a later episode is the thought. It's a good thing to have, that you can connect this to the computer and you get the waveform into the computer to use in other programs. Let me get the resistor. Don't burn out the LED, because now if we connect this, turn this on and press play, the LED is shining. Good. So now we have what this means, what we can do with this, because we have the other pins as well. Now we have clock. What did we say? We said clock was this one actually. I need to check this again. I think we said white was clock. What this means is that we could, if we want to, so we have enable pins on these. These we could pull low when the clock goes high, for example, and that way this one will only run when the start is running, and it will stop at whatever step it is at when it goes low. reset, we also need to connect to the reset pins, I'm guessing. See, this is it. We're not running right now. So we actually need to do that. We need to get the clock, the start-stop pin to the enable pin, because now we're running, now we're not, and the clock is still running on this port. Right. So if we take that there instead, it is blinking really fast. So now we know. So what do we do now? We take the pin out diagram of the 4017, which is the one we're gonna start with. So one of the bad things here is if we want to use the enable pin, then we need an inverter as well. So I'm making room for that if we decide to use that. And I'm not putting in any of the protection circuitry and stuff like that. We're going crude, just the chips and the clock straight into the chip. Clock is on pin 14, so that's the third pin from there. And then we should have some power and some ground. And we get that from an Arduino because I want to run this at 5 volts. We could, again, if we want to make this into a module, we can run this on 12 volts because these can handle 12 volts. We just need to add a, what was it called now? Not voltage divider, yeah. The thing I did a few episodes ago that makes that puts a threshold at a point. Man, how can I forget that? It'll get back to me. And that is ground. Let's put ground over on this. No, let's not. Let's put a bit smaller resistor, so maybe we get a bit more light out of the LED. So let's put this on pin, some pin 9 maybe, 10, that one, just to see that we actually count all the way up to that pin. That would probably not happen because we need to pull the enable pin low, of course. Enable is pin 13. That's the one next to that one. And need to do a lot here. Let me just check the chat. Yeah, exactly, Al, with the scope. Sync on Volcas, yeah. We have to look at that. I don't have a Volca, but I think that sync is similar to Sync24. I don't know. I was sitting thinking why it is Sync24, and I'm guessing that is because it's possible to divide it both by 4, so 4 on the floor, but also with, is it 24? Not 3. Is it divided by 3? No, you can't divide 24 by 3. But you can divide it by 6 and then by, so it becomes by 3 by going to 12 and then divide by 3. That's what I thought. So some kind of walls maybe that they want it to be able to do that. I don't know. Reset. So we said we count to 5 and then reset. And so when both enable and clock, when reset is high, clear counter 0 is high, so that means when we come to 5 and then when we go to 6, that will pull the reset and turn 0 high, so we put it on output 6, which is pin 5, 4, 5. And then we take, so output 5 then is pin 1. I just have ground over on this side as well, I think. Yes. Now I don't know if you can see this, but it is already blinking, and if we compare that to this one, it's kind of the same speed actually, but and that was a strange speed as well. Pattern plane. Anyway, back with the light. So we are halfway there. So we now are down to, we divide by 6. And then, so this one should go and into clock input. So now we need to go to the second chip. That's also clock on pin 1. And we'll get the other one in a bit. We start with this one, clock and enable. Let's see. Enable is high, count. When enable is low, we don't count. So this one needs to be high. The other one needs to be low. This one needs to be high. That's Interesting. So that's that one. And when reset is high, Q0 to Q3 is low. Which means we need to, on the second bit, we need to have an output and the reset. Is that correct? No, that's not correct. We should have the reset on bit number 3. Q0, 1, 2, so pin 5. Let's see. We should have reset in another color, shouldn't we? 1, 2, 3, 4, 5, that's Q2. To reset is pin number 7. And we connect this to see if we have anything. We do. We have a slow pulse there. Chant sauce, be warned. I'm guessing we'll still talk about the oscilloscope. Yeah, get it from their webpage. I guess that's a good source. So let me do this. So this is now, let's see which this one is. It is divide by someone. So this should be the tempo. And it is, right? Yeah, it's the tempo, but it might be, yeah, it is the, again, it's this problem we had with the clock divider as well. It is inverted, so maybe we need an inverter anyway. Let me get an inverter. A 4069 should work for that. Just gonna bend the legs here. And I need the pinouts for that one, just a moment. $4069 hex inverter. So then we can use, we need to use one of these inverters to invert the output signal. and then we need to use the other inverter, one more inverter. We have 6 inverters, so not the other, but one other, to make the enable pin or start stop pin, that is the red one in this case now, then out from the dramatics into, so it should be high on one pin and low on the other one. So what this really means is, I'm messing up the colors here, but don't really need to remember this maybe. So the start stop pin and to enable pin on the 4520 is 2, pin 2, which was that one. So if we, so now it is not running, but if we press play again, if we press play, it is running, right? So then we need the inverter, fresh from the printer. So we have input there, and we take that from the start stop into the inverter, and then going from the inverter into the 4017 reset, which was pin 15. So that is no, not reset, enable pin 13, that one. So again, it is running, it is not running. And it stays high for some reason. Yeah, that depends if it's up or down. We need to, what did I say the other one was going to be? Right, that was going to be so the outputs need to go into 2A, that's that one. We can have a few different outputs, so now we have quarter step and we can have 8, and we could take more or shorter divisions up this line. So I think we can have 3 as it is right now. There. And that is the output now. This is going really well, I think. And yes, it's working. Maybe something to prove that, or something. Such a strange pattern, though. I think it's been reset or something. Ah. I don't remember how to do this. Bar reset. Ah. There's not a single one that is just 4x4. Oh, there, we got one. I think it's too slow actually. Let's see. Just move this one up one step there. 3. Yeah. Yeah, the sync. I need some other sound maybe, so I have something to listen to as well. Because if we just so now it is double sync. So I'm just taking the pin, the start stop enable pin that I for the chips. So now I can make it enable start stop just by changing that pin. But again, I think we're missing one thing, perhaps, because we're only sending we need one more thing. We're only sending the clock and the start stop. We don't send the reset, so we never start from the beginning. So we need the reset pin as well. Right, so now we need to start stop was red. Maybe I should read red. And look, we have a blue cable. That's good for reset. So that's the one next to start stop. Right, so this is the reset, and the reset sorry, I should have had schematics for this, but as I said, I didn't think of this in the beginning. Let's try to think about this. The reset should reset both chips, but we can't connect those chips together because then they will reset each other. So we probably need a few diodes could work. But we need to check, so the inverter is not interesting here. Reset high, yes, so we need to pull the reset high on that one and reset high on that one. That's good. So that means that the diodes can go towards the chip on both, so you don't need to think about which way they should be pointing. Or pointy birds, or pointy. That said, let's just do that. No, that's not. I want to know if this one is high or low. That is what I want to know when reset is running. So we run and we stop. Nothing. So it doesn't make a reset. Alright, so the reset isn't needed then, because the reset doesn't do anything. Then how does it keep in sync? We would actually need one little circuit that I can't build that now, but we would need a circuit that actually pulls as when you press start, it would send a just a pulse to both resets to reset the whole circuit, because this one always starts from 0, so it should actually or we take reset, so when start stop goes low, we take that signal into inverter and then into both resets, resetting the whole circuit when it is off. And then we won't get that. No one, any ideas? Would that work? That could work. Couldn't it? Yeah. So the red one, no, I need longer cables here. Start, stop, going into an inverter. Number 3 is 5, 6, for example. 5, 6. And that then goes to reset on pin 7. But also to reset on that one, pin 15. So now it's not running, and when we press play, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Maybe it's which one was the one I had? This one is really messed up. There's like can't even do patterns. I don't know why. Something has happened. It's still too slow though. One, two, three, four, one. I don't know what to say. It is in sync, but, or it is in the same speed, but if I should play this, it would probably be a bit off. That's not optimal. Give me a sec, I'm just gonna move over to the modular and see if we can get some sound out. I just need to find a jack. I usually have a few of them lying around here for experimental purposes. Here's one. So that one is out there. So I'm going to remove the LED. Should I? No, let's leave it a bit longer. So give me a sec. Okay. Let's see, gate. Let's put the bass drum we did. And you're standing on that 606 right now, so technically this should now make a drum. looks very unstable actually. Take something easier. That one didn't work. Just bad cable. Come on. And then take the output of the TR606. It is actually blinking very good in tune with this tone right now. So we have the beat, it's just that my 606 is not feeling well today. Anyway, aside for the fact that the drum machine is not playing with me as I'd wish, we actually, and that was probably, I mean, of course it works. CMOS circuitry is from the time that this one was made, so of course it was made to be able to get the clock output from that one with this one. So the only thing, yeah, we can try that as well. Let's, so I'm going to connect this one, no. I'm going to connect enable pin again. Which one was that? Let's just connect the enable pin again. To that one, right? So now it shouldn't sound, and when we play, now it does. Maybe that's for the reset. We press the reset button here and to turn it off if it stops in the on position. So anyway, it works. We can make a Sync24 with just 3 CMOS circuits, the 4017, 4520 or any other binary counter, and a 4069 inverter, and we have ourselves a Sync24 DinSync 2 gate signal to put into a modular of some kind. So that's good, and we run it from 5 volts, should be able to run from other voltages as well. Yeah, so hi, by the way. That's it for this. Thanks for watching, and I have a few more. As you know, or as I've already said in a previous video, I'm just trying to get out as many videos as possible that doesn't have to do with the modular in a week. Now this one did, and this will definitely become a module of some kind, but I'm still waiting for components. I've got one package of 3, so it is moving. Anyway, until next time, take care, bye.